In my last video, I discussed my mixer board. Now, each one of my boards over here out of frame, or it's in frame. This is a 455 board. This is a mixer board, and this is the RF board. Now, what I did was I used basically this circuit from that book I showed you. Okay, it's a FET amplifier. But what I did was I changed this output to go to another coil through a capacitor. And what I did was I took the circuitry from a Collins, I believe it was an R390, and you come in, now my antenna would come in over here. You come in on this first coil, and this coil is a T50-2, and it's not temperature compensation. You don't need temperature compensation in this application. You use the yellows for in your oscillator section. So you come in here on the first T50-2. It's got 6 turns, and there's two wires, or 2 connections for the coil. It's 6 turns, and in this case it's grounded on one side, and then I come in with a long wire. You come into the coil, and here's your potentiometer, and when you turn this, it varies the voltage on a MV AM 109 varactor diode. Right? Then we come over here, this pot, and there's a FET hiding under this wire here. Right here there's a FET, and it's the same as this. Right? So I can control the gain of this module with this by turning this potentiometer. So you come in the first coil and you tune. All right. So now the this unit tunes between 3 megacycles and 8 megacycles, and you come in, you tune it with this knob for say 3 megacycles, and then this allows only 3 megacycles theoretically to get through, gets amplified, goes through 2 more stages of filter. All right, it's an RF filter, and then it goes into your mixer and the crystal oscillator, which basically down converts the band that you want to receive, and then it gets uninverted or inverse. The band gets this inverses the band, so I can use a digital frequency counter. It's a little bit different, and I work with modules, so I can upgrade a module. Now, since the last video, you notice the mixer module got upgraded. All right, I think it's around here somewhere. It was actually the RF front end and 1 mixer, and then on a proto board I had another mixer, and now I like the way it worked, and this is over here. Now both these NE602s have their own crystal. Originally I was running both of them off the same crystal, but by running them off separate crystals I can run other experiments. I can come in and use a 10 megacycle crystal here and a 9 over here. I don't know what it's going to gain me, but I have the option. And then this RF mixer comes off the tunable oscillator with the digital display, and that creates the 455. But I want to talk to you today about the front end. Now, if you go look at real shortwave radios, and when I say real, I want to talk about stuff the military used. They later on went to transistorized, but if you look at a military radio, the front end has an incredible amount of coils. And radios you buy, ham radios, they still have some coils in there. And then the portable cheap crap that you get on Amazon has even less coils. SDRs have almost no coils. There's certain things the radio has to have to work properly, and they've dumbed it down. I explained to you years ago that when radios first came out, and military radios came out for the war, they put on everything they thought they might need on the radio. Now, when radios came out and they were sold to people, originally they ran on batteries. rechargeable batteries. And they had an extra IF can section. They had a big RF amplifier on the front end. That's because they sell you the radio and they want it to work for you. And then as time goes on, they take these parts out of the radio, knowing that the public is freaking stupid. All right? They know most of the public is going to listen to the closest, loudest station. So why put all those extra parts in there? You charge them for those parts, but they're not in there. Now, the SDR radios basically have no front end. They do have an RF amp that you can switch in and out. So if you switch to a whip antenna, they have an RF amp that kicks in. But there's only like one coil per band. I mean, one little tiny ferrite coil. It's not even a coil, it's a choke. They're junk. And if you read the reviews on Amazon, any model, you half of the people figured out this thing doesn't work that good. One guy will say he's using a hand scanner, it's deaf compared to his hand scanner. That's right, your hand scanner has an RF amp with some coils in it and filtration on the front end. SDR it gets all these different frequencies, but there's no front end. It's just wide open. And if you put it on FM, it works great. You put it on AM on the strongest station, AM broadcast band, it works great. But you can't DX the AM broadcast band. So they dumbed it. It's dumbed down. It's like the tabletop radios back in the 50s. They the 5-tube, all-American 5 radios. They put the least amount of stuff in that radio because they knew people listened to the local station. So as you get into radio, someone gives you one and it might have a shortwave band on it, and you turn it on, you go up and down the band, you find like 3 shortwave stations when there should be like 40, minimum 40. And you don't know what's going on. That's because it's got no RF front end to amplify those stations. You want two things. You want to amplify the station and you want to reduce noise. So how you reduce atmospheric noise and all that, you make it a tuned circuit. So the tuned front end also starts to make the radio narrower or better selectivity. So then you come in, you dual convert, or you just convert once, then you go into an IF strip, which makes it more selective. If you have 3 IF cans, it's going to be more sensitive than one with only 2. I look at schematics of radios before I look at the radio, before I look at the spec. Now, I have a closet full of ICOM R71As that I repaired, and I kept as a collection. And I'm looking at the front end on the radio, and it's bogus. And I know they did the specs for that radio on one of the on a frequency that's the front end is actually doing something to it. You look at some of these crappy shortwave radios. There's these bandpass filters. They have a couple coils in them, a couple chokes, capacitors, chokes, and resistors, and they're switched in and out digitally by the microprocessor. So if you're going to do the specs on the receiver, you're going to make sure one of those is switched in and you're in the middle of its tuned range, and you do your specs there. I never realized the R71A, it picked up a lot of stations, but it also picked up the noise from its display, its processor, its mixer made noise, and when you're in sideband, it worked great. You didn't notice anything. Then you go on shortwave, and it wasn't that great. I mean, it just didn't sound like an old tube radio. And then I found out that they put the wrong value in the tone section of the radio. I'm the one that figured that out. So you disconnect that capacitor. Now you get the high end of your audio. There were guys that did all mods and stuff on that radio to try to fix the problem, when really it was a design error. So I wrote it up. It's on the internet somewhere. It's the tone control capacitor. You can go in and you can disconnect it at one of the connectors. You don't have to desolder or anything. And I did a video on that. That's gone. That's one of those deleted videos. I started getting hit with people that wanted me to fix their radio. And I don't want to fix radios anymore. I like to build them. My next thing to do after building this front end is to have feedback. In other words, you call it an AVC, automatic volume control, or in other words, not frequency, it would be signal control. In other words, you want to, whenever the signal's strong, you want to develop a DC voltage in your detector circuit and feed that back to the front end. And at the front end, you turn your amplifier down. That's why this unit has an amplifier. So you turn that down, and it prevents the radio from overloading. Now, a lot of your SDRs don't have that. That's just wide open. And you can control the gain of an SDR by going in the software and going up and down buttons. That's getting you so busy with the software. So everything about the radio is software defined, but there's certain things that a radio should do automatically, and they're making it a feature. All right, they're undoing a feature to create a feature, keep you busy. Wow, it does this. Wow, it did that. Now, this one guy reviewed an SDR. He had one that was the Russian made and one that was a clone, and he kept saying how good the clone worked until he burnt it out. But he's reviewing two radios, and one of them's burnt out, and he's showing you what's wrong with it. And what a horrible review. And the guy's quite smart at repairing, but little by little, I'm starting to see what he doesn't know. And I was like watching that review, and I'm like, tell him that there's no front end on the radio, but he doesn't know that yet. He's never looked at the schematic, and if he goes to repair one, he's going to get the shock of his life. But go look at the schematics for Collins stuff and Raycal. Go look at the Raycal shortwave radio for the military. It's got all these filters for the front end, bandpass filters, and I've been looking at that, and that's considered the ultimate shortwave radio. Now, there's people that'll argue with that, but those things go for up to $6,000 in mint shape. We're talking a radio. And a lot of people say, well, it doesn't do satellites. It doesn't. Well, you got to draw the line. You need, if you want to do the full spectrums of radios, you really need a really expensive radio or 3 better radios. And that's how you're going to have to do it. Your SDR, those were made to get television on a computer, and someone figured out, well, we can redo the software and we can pick police up on it. Police, fire, aircraft. And little by little, in order to selling feature, they kept dropping the frequency, raising the frequency, and it does pick up the strongest signals on different bands. But it's not even an entry-level radio. They keep saying that. You don't use that phrase with an SDR. An entry radio would be like you get a used Radio Shack DX390 for shortwave. It does FM stereo, it does AM broadcast really well. You got to really look at the schematics. You got to understand the schematics. And I show you, I build it from scratch, and get it working. And wind my own coils. This is sort of this is exactly a front end from a Collins, modernized. In other words, toroid coils instead of those tubular coils, and because they could be in a smaller space. I don't know what the Q is, which would be the amount of signal that the coil passes. A coil is a passive device. It uses energy. So in other words, as the signal goes through a choke or a coil, you lose signal. So you come in, you tune it, and you amplify it, and then you come back out to a double filter, now to your mixer. And one thing I noticed on this, which is really amazing, you leave the local oscillator, the digital display at 3 megacycles, and you tune this front end between 3 and 8 megacycles, and at 6, double the frequencies will come through, because the oscillator in the radio at 3 is also creating a second output, a multiple or a harmonic at 6. So you can actually get, if you detune the front end, you can actually get, when you're set at 3 megacycles, you can get a station at 6 something to come through. See, when you have a test bed like this, you're able to run all kinds of little experiments. The one thing you can do is you could take the front end off and just put a variable RF amp in, just like an SDR, and realize what a bad design that is, what a bad mistake. And I don't care what country it's made in. And I have guys, oh, you got the cheap one. You should have bought. You're talking a non-radio. You're talking a fad. Something that's, it's a piece of junk. Okay, 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 okay. So I just want to show you what I'm working on. And the next thing is the automatic volume control circuit. See, I never built an AVC circuit into one of my shortwave radios. I left it straight out, because I was using it to listen to sideband. And when you listen to sideband, you turn the AVC off. You run manual volume control. And there's so many experiments that I want to run, and I want to read up on toroid coils to find out how much gain, or the Q of these things, how much do they waste compared to a cylinder coil, even the best wave wound with the Litz wire. But I use most of my circuits. I stay down this one will do 40 meters. It'll do 80 to 40 meters. I stay at those frequencies because at night those are the most active, and I do my final experiments just before bedtime. And those are the bands you're going to find stuff on versus during the day. During the day, I have a different set of hobbies. But I wanted to show you, I did redo my mixer board. I took it to the next level. There's 3 mixers on there. There's 3 NE602s. You won't find that anywhere on the internet. And then this is basically a Collins circuit modernized. And this is a real front end versus the Raycal. The Raycal's got some really hefty bandpass filters. And what I've been doing is looking at the schematic, and then I got to go read. And I have to be in the mood to read it, and then read how it's working. Because these really good military manuals, they go step by step, what each part does, and they explain the thing how it works, versus some guy in one of the conferences on the internet. I just wanted to show you that. I think that's it. All right, that's it.